Cool. All right, so looking at our do now today, I gave you calcium carbonate and I gave you 3 compounds of it. So let's break that down, figure out how many atoms we have with each element, and then the total number of atoms. Really great refresher from what we talked about in our last lesson. Some things to keep in mind. Is this an element, compound, or mixture?
Mixture.
Compound. So the reason why it's not a mixture is because these guys are chemically bonded together. It is not an element because I have 3 different atoms there. So since I have 3 different atoms that are chemically bounded, I have a compound. I don't have an element because I have multiple things there. All right. So let's break down how we apply the different rules when we're looking at our formulas. So keep in mind that we have things called subscripts and we have coefficients, is what we've talked about so far. A subscript are the numbers behind the elements. If there's no number there, it is just 1. In this case, the only one with a number that is not 1 is my oxygen, and that is 3, and that 3 only applies to whatever is directly in front of it. You should rewrite. You should have the answer. If you don't have the answer to the do now, you can copy my answer down. So that's the first thing we're keeping in mind. The second thing we have to keep in mind is our coefficients, which are the ones in front, and that applies to everybody behind it. So it's going to apply to the calcium, it'll apply to the carbon, and it'll apply to the oxygen. So let's first start off by counting my calcium. I have 1 calcium atom, and in fact, I'll keep with the color code so that way we're keeping track of subscripts and coefficients. So for calcium, I have 1 atom, because there's nothing written behind that. And then I am multiplying it by the 3, because there's a coefficient in front. And so my total number of atoms of calcium is 3. Good so far? All right. Next one is my carbon. Carbon also has no subscript behind it, so that is 1. Yep. Again, I'm using that same coefficient as 3. So 1 times 3, I have 3 carbon atoms. I'll move it out so we can see all of them now. And then last one we have is oxygen, which is that O there. I see with its subscript, it has a 3. So I actually have 3 oxygen atoms to start with. I am multiplying it by, again, that coefficient in front, which is 3. So 3 times 3 is 9. So I actually have 9 oxygen atoms, quite a few. And then when I want to figure out total number of atoms, I just add all these guys together. So 9 plus 3 plus 3, how many atoms? 15. And that's how we do that. Don't stress if you're still kind of a little on this material, because my plan is for tomorrow to give you guys kind of a study session, so that way you guys can catch up on homework and just do some more practice. Okay? Okay, can I move it? Cool. All right, let me pause the recording. Okay. I'm going to be writing some statements down, and I want you to give me a thumbs up if you think that statement is true, or a thumbs down if you think that statement is false. Huh? If we have time at the end. All right. Thumbs up if you think my statement is true, thumbs down if you think my statement is false. So my first statement that I have for you guys are atoms and ions are the same thing. You don't need to copy this down, but if you feel like you need to, you're more than welcome to. Atoms and ions are the same thing. Thumbs up if you think that's true. Nice and high. Up in the air. Thumbs down if you think that's false. You are right. It is false. So that is not true. They are different things. So when we are talking about ions, we are talking about atoms that have gained or lost electrons to become stable. All right. My next statement for you guys is an atom that loses electrons will become negatively charged. An atom that loses electrons will become negatively charged. All right. Thumbs up if you think that is a true statement. Thumbs down if you think that's a false statement. Where are we going? Thumbs up, thumbs down. It is thumbs down. So, the thing we have to remember about atoms that lose electrons are negatively charged. To capitalize it, model good writing. So electrons are negatively charged. If I lose a negative charge, I then become more positive. Now, just so we get some extra vocabulary, positive ions, those are known as cations. The way I remember them is I think about a kitty cat, and I'm like, the kitty cat makes me happy. It's very positive. Get it? Positive. It's dumb, but it works. Yeah? Do you guys want an example of an atom that does that so we can understand why it's positive? Are you guys okay?
No, we need.
You need an example? Okay. Let's say, for example, that I'm talking about sodium. So Na. And I'm talking about Na+. In this case, we have lost an ion. So if I look at the atomic number is going to be 11. Now, with that 11, that means I have 11 protons. But since I have lost an electron, how many electrons do I have if I lost one? 10. So I have a negative 10. So that's for my protons. That's for my electrons. If I add those numbers together, what do I get? Positive 1. Positive. So when we write the sodium ion, it would be Na+. Positive. Right, I'm just going to move this up, and I'll get my next statement writing. Might zoom out a bit. Okay. The next statement I want you to decide if it's true or false is, if an atom has 3 or less electrons in its outer shell, it will lose those electrons and form a positive ion. Now don't worry about copying all these statements down because remember I gave you that reading passage and all the answers are in there. All right, so is that true or false? That is true. It'll be easier for it to lose electrons than gain them. All right, next one. An atom that gains electrons will be negative. Just move that up. All right, thumbs up, we think that statement's true. Thumbs down, we think that statement is false. It is true. So remember, those electrons are negative, so if I gain those electrons, I will become negative. Again, adding some extra vocabulary for you guys. These negative ions are known as anions. And the way I like to remember anions is it looks kind of like the word onion, and onions make you cry, which is something you don't want. Here's my little onion. It's like, no. That's a bad looking onion. Onions make you cry. Okay. Next one. I know there's a lot, but I want to make sure you guys got the reading passage. Okay. If an atom has 5 or more electrons in its outer shell, it will lose those electrons to form a positive ion. So if an atom has 5 or more electrons in its outer shell, it will lose electrons to become positive. How many think that statement's true? Thumbs up. Thumbs down if you think that statement's false.
False.
It is false. That's not true. So if we were to fix that statement, we would say that it will actually gain electrons and it will become negative. That's how we fix that statement. All right. The last statement I have for you guys is polyatomic ions are ions that are made up of more than one element.
No.
True or false? What are we thinking? Polyatomic ions, they're made up of more than one ion.
Oh.
True or false?
True.
It is true. They are made up of more than one ion. So, if we look at our sheet here, there's information on polyatomics, and they give us a list of potential polyatomic ions, and they talk about what their formula would be, and also what the charge of that polyatomic ion is. Huh? With a paper? All right. Let's have a chance to practice that information. So I will pass you out a worksheet on formation of ions. There's, like I said, a stamp here for the self-reflection, which I think is useful to do, so that way you guys can double-check your understanding and your... Once you have it done, you can glue it in. Oh. Alright, good to go. Let's do now with the concentration. Yes. If you guys want to listen to music while you work on this, I want to make sure you guys practice it. This worksheet here. Processing time. Alright, that's what you guys are working on right now? Do I have you guys on a Monday? Grace, I don't have you on a Monday. I have you guys on Tuesday. Wait. That's cool. Sorry, we said class. I'll get you the notes and see it. I gave all these questions. I gave all these questions. Oh, it's the same. Based on the 3 days of fiction. I want you to be the first. Let's see what time the lesson ends. So you guys are where? I'm where? 10:30? I haven't memorized the new timetable yet. Maybe can you tell? Yeah, 10:30.
There's some work out.
Yep. So then it's that's the 0. Good. Yeah, use the homework from the other day because you did the exact same thing. Using those electron configurations. You guys want me to do something for examples? You guys okay? Oh, I need a periodic table. Oops, forgot to stop that recording. That was my bad. All right. I have been asked to do some examples to help you guys get started. If you already fine, feel free to keep going. If not, listen up. Okay. So, what you're going to do is you're going to look up the element on our periodic table. First one here is hydrogen, and the atomic number is 1. So I only have 1 electron. So when I go to do my electron configuration, I just write 1. Now in this case, easiest thing for it to do is to lose that electron. It's going to lose the 1 electron. Ladies in the back. Since I've lost 1 electron, I have H plus as my new ion. The electron configuration for this case, because I have no electrons there, is actually just nothing. 0. I'll do 2 examples to help. Alright. Nitrogen is the next example I'll do for you guys. Nitrogen has the atomic number of 7. So, 2 goes into the first shell, 5 into the second shell. Now in this case, we talked about in our reading passage that if it has 5 or more electrons, it's going to gain them. How many do I need to gain to get to 8? 3. If I gain 3 electrons, that's 3 negatives, right? So now my nitrogen is 3 minus. And then my electron configuration is now 2, 8. You're going to notice a pattern with the ions, and that's going to be, it's really repetitive and what their electron configurations are, and that makes sense because they're all about that stability. Are we good? Feel better? All right. Get her done.